This video is about what confusion matrix is and what are the metrics that we can derive from the confusion matrix. So, when you're doing a classification problem, machine learning using a supervised learning algorithm, it means that you know the labels or the target values for some of the data points. So you know what is true or what is the category for the target variable basically. So now you use the machine learning algorithm and predict the category. And when you summarize the actual target values versus the predicted target values in a matrix, that is called confusion matrix, also called as error matrix. Now, in general, the terminology used is positive is when if you have a disease or if you are trying to identify something and it is there, that is when we call it as positive. Negative is a terminology used when we want to say you don't have a disease or you did not have a particular attribute. True positive means we predicted as positive and that is true. That is, we predicted you have a disease and that is true. That is when it's called true positive. True negative, we predicted it is negative and that is true. So in this case, if we say you predicted you don't have a disease and that is true, that is called true negative. And true positive, an example is a customer is actually pregnant. We predicted them as pregnant. The particular person is predicted as pregnant and they're actually pregnant. So we predicted and that is true. We predicted as positive. Pregnancy is considered as positive in this case. We predicted as pregnant and that is true. That is called true positive case. False positive is we predicted as a woman is pregnant but it is false. She is not pregnant. That is false. False positive. And this is called type 1 error, false positives and or false alarms. And this is considered a bigger problem to be avoided. So false positives, trying to decrease the false positive cases is generally considered important, but it depends on the business context. True negative is we predicted as negative and it is and it is true. That is, we predicted negative. That is, we predicted a person as not pregnant, and that is true. That means the customer is not pregnant in reality. That is true negative case. And false negative is when you predicted as negative and that is false. So you said customer is not pregnant and that is false. So this is also called type 2 error or it is also called a miss. You have missed case. Now the total positive ones the total positive ones will be the true positive cases which are positive and that is true, that is positives anyway, and whatever you predicted as negative and they are false. So these are also positive cases in reality. So the total in reality positive ones are true positive plus false negatives. The total negative ones will be the true negative ones, which are negatives in reality. We predicted negative and they are true, which means they're really negative. And we predicted positive and they are false. That means they're actually negative. So true negative plus false positive. These are the total negative in reality ones. Total decisions that we need to make are whatever are positive cases plus whatever are negative cases in reality. Sum of those is total decisions. And total correct decisions we made will be whatever predicted as positive and that is true. That's a correct decision. Whatever predicted as negative and that is true. That is also a correct decision. The metrics now are precision is one of the metrics which is also called as positive predictive value precision. So if you see the confusion matrix, We have the actual conditions. So these are the positive cases in reality, the negative cases in reality, and these are the predictive outputs we got. We predicted positive are this, predicted negative are this, and what we predicted positive, and that is positive, that is true positive. We predicted positive, and that is actually negative, that is false positive. We predicted negative, and that is positive, that is false negative. And we predicted negative, and that is negative actually, so that is true negative. So in this table, if you see, what is precision? Precision is out of whatever we said as positive. So we said predicted as positive, out of whatever we said as positive, that is the total this, that is true positive plus false positive. Out of this, whatever we predicted as positive, how many were actually correct? Actually correct are true positives are actually correct. So positive predictive value, also called precision, is out of whatever we said positive, that is predicted positives, what are actually correct? True positives. So among the ones we said we predicted as pregnant, how many were actually correct? That is an example of precision metric. And the counterpart to that is positive predictive value. The counterpart is false discovery rate. So whatever is positive predictive value, if you do 1 minus the positive predictive value, you get false discovery rate. So you predicted this predictive positive predictive uh, when you take 1 minus that, it is the falsely discovered count percentage actually. Next thing is negative predictive value. So on the other side here, we predicted negatives. So it is predicted as negative and it is false. We predicted as negative and it is true. This is predicted negatives, total negatives. So out of these, false omission rate is, out of the predicted negatives, what is falsely predicted? That is false omission rate. And out of the predicted negatives, what is truly predicted? That is negative predictive value. That is negative predictive value. Accuracy is total decisions, whatever total decisions we made, it is positives plus negatives. And on top of that, we put total correct decisions we made, that is true positives plus true negatives. That will give us accuracy. So we are dividing into denominator by the total women in this case, and the total correct decisions are the pregnant ones, which we predicted as pregnant, plus the non-pregnant ones, we said non-pregnant. So they are the true cases, true by the total women. Pregnant cases by non-pregnant cases, which we correctly predicted. Recall, also called as sensitivity, also called as true positive rate or hit rate, is the next metric. Here, if you see, what recall means is how many of the positive cases did we recall properly? We were able to identify. How many did we identify? That is called recall, all true positive rate. So if you see here, the true positive rate is nothing but out of the positives, means in the denominator it is the total positive count is there. How many did we recall? Means whatever we said is positive and that is true. That is what we were able to identify. So out of the positives, how many did we recall? True positives. So that is true positives by total actual positives. Denominator has total actual positives. Actual positives are nothing but what we predicted as positive and true, and what we predicted as negative and false. That is the actual positives. And on numerator we will write the true positive, how many we were able to really identify among the positive ones. It's also called as power. True positive rate is also called as power. Recall is also called as power of the test. Sensitivity, and a good way to remember that the formula recall formula is true positives by actual total positives count is sensitivity has n in it, but the formula has only p's, the positives in it. And this is giving the probability that the test result will be positive when the disease is there. So when the disease is there, actually the probability that this test, a particular test, for example a COVID test, we're doing RT-PCR test, when the disease, when the person has has COVID, and if you're doing this RT-PCR test, how much is the probability that the result will be positive? So if you are doing, if you take a RT-PCR test and you do the test on multiple people and classify the people as COVID cases, non-COVID cases, and then create a confusion matrix and calculate the sensitivity or recall metric, that tells us how sensitive the test is. What are the, when there is a disease, what is the probability that the test will actually predict that? In other examples, out of all the pregnant cases which are total positive, how many pregnant cases did we identify correctly? True positives. Among the total people with disease, how many disease people did we identify correctly? Now the counterpart to that is false negative rate, which is 1 minus true positive rate. So here it is, this is true positive rate here, and the other side is false negative. So false negative rate will be also called as miss rate, is the sum of these is 1, is total positive. So the denominator will give positive. So false negative rate will be 1 minus true positive rate. So recall, sensitivity, true positive rate, hit rate, power all mean the same. Specificity, also called as true negative rate, also called as selectivity. Specificity is, in this case, what it means is out of all the negatives, how many did we correctly identify as negative? Out of the total actual negatives, how many did we correctly identify as negative? So out of the total negatives, real negatives is here the total negatives, sum of these two will be the total actual negatives. So the denominator will be the false positives plus true negatives, which is total negatives, or here it is simply indicated as n, the denominators. And specificity is how many we actually identify as negative, that is true negative. So true negatives is in the numerator. When we do this true negative by total negatives, we get specificity, also called as true negative rate or selectivity. And the counterpart of that is false positive rate, which is 1 minus true negative rate. So when you get true negative rate, which is specificity, the counterpart is here false positive rate, which is nothing but 1 minus true negative rate. Out of all non-pregnant cases, that is, out of all the negatives, how many were correctly identified as not pregnant? That tells the specificity. Among the total people not having a disease, say COVID, how many did we correctly identify as not having the disease? False positives. Sorry, this is not the wrong thing. Not the right thing. Here, out of all the people that are not having COVID, how many were correctly identified as not having COVID? True negative by total negative. That gives us specificity. True negative rate is 1 minus false positive rate. Now, before we go to the F score or F1 score, we need to know what is harmonic mean. So arithmetic mean, geometric mean, harmonic mean are just various ways of summarizing the data to indicate a central point in that data. and one of those formulas works best in based on the situation or the problem in question. So arithmetic mean, when we're dealing with raw data values and you want to find a central point, arithmetic mean works best. And when you're dealing with derived data from raw values and you want to find a central point, then geometric mean works better. So if you're having percentages, so you have raw data points and you took percentages, now you want to take average of percentages, then you don't do a arithmetic mean, you do a geometric mean. Mean calculated using product of observations is geometric means. That is, if we have certain uh, derived data matrix here, a, b, and n, the geometric mean of this is product of these raised to the 1 by n, nth root of that is geometric mean. So, and for example, if a and b are the two values that we have, derived values from the raw values, geometric mean is square root of a into b. Harmonic mean is when dealing with fractions of given data. Of the raw data points, we have some fractions. For example, in case of stocks, we have price to earning ratio, earning per share, price by earnings per share, P by E, P by E is the formula. If we have those P by E values for certain stocks and we want to find a mean of those P by E's, harmonic mean works best. So probably if there is a certain industry and we took some stocks from that industry, we have the P by E values and we want to find the average P by E value probably. I think we will use this thing. Harmonic mean works best. It works when we are calculating average of the rates here. This is what we are calling rate. Rate means something measured as a unit of something. Something expressed as unit of something else. That is rate. So for given observations, raw data points, we take the reciprocals first and find new set of observations. So 1 by is what we do for all the existing values. Then take arithmetic mean of those. So the way to calculate harmonic mean is take the data, take the reciprocals of all the data points, then take arithmetic mean of those reciprocals. Then what you get is called harmonic mean. And if you have weights to be given for each of the data points, the sum of the weights should be in the numerator. So if you assume the sum of the weights is 1, that means if all the data points should be given equal weightage, then sum of the weights will be 1. So the numerator will be having a 1 in this case. So with that knowledge, what is F score? F score is nothing but a harmonic mean of the precision and recall matrix. So we calculated precision earlier and recall. Now precision is nothing but positive predictive value, which is out of the total positives, how many were actually correct. So true positives by total positives. And recall is sensitivity. So out of the uh, out of the actual positive ones, how many did we recall? So out of the total positive ones, in reality, how many did we recall? That is true positives. So once we calculate these two, if we are having a business scenario where we consider precision and recall to be of let's say equal importance in that case, so we're giving equal weightage to these. Now we want to take harmonic mean of this to arrive at F score. So precision is, as we saw, it's a fraction. Recall is also a fraction. true positives by x total positives. Precision is true positives by true positives plus false positives. So we these two are obviously fractions, and now what we're doing here is uh, first we're taking reciprocals of those. So one by precision and one by recall is what we converted them to. Then we're taking arithmetic mean of those. So arithmetic mean is sum of the values by the count. So we're adding them up and dividing by 2. And what we get is this. So this is the harmonic mean, and it is nothing but 2. Uh, okay, we took the arithmetic mean, and then we had to take, I think I said that incorrectly. So once we take the arithmetic mean of the reciprocals, then we need to reverse it again here. Harmonic mean. 1 by arithmetic mean is what we need to do in that. So first take reciprocals, then take arithmetic mean, then again take the reciprocal of that arithmetic mean. That is when you get the harmonic mean. So 2 PR by P plus R is what we'll get as F score.